Hi guys, magandang araw po sa inyo lahat. This is Sean from Keep It Up with Sean. And pasensya na, mali pala yung na-upload ko na video about the part 3. So this will be the third part of this lecture series in which we are going to talk about soil orders. Sana meron kayong matutunan about this topic and let me know kung meron kayong mga questions. Maraming salamat and see you again next time. Bye! Now we go to soil taxonomy. Alam na natin kung paano natin yung mga basic criteria kung paano mag-classify ng soil. Now we are going to go one by one. The soils are classified into 6 categories based on diagnostic characteristics. Number 1 is the order. So there are 12 orders. We have suborders, grade groups, subgroups, family, and series. Ang daming series. So each country has their own series. This is based from Bull, Hole, and McCracken when they differentiate characteristics of the soil. So the order, ano nga bang ibig sabihin ng order? So these are the highest. This is a soil forming processes as indicated by presence or absence of major diagnostic horizons. Order. Suborder, this is the genetic homogeneity, the subdivision of orders according to presence or absence of properties associated with wetness, soil moisture regime, major parent material, and vegetation effects as indicated by key properties like organic fiber decomposition stage in histosols. And then we have the grade group. This is the subdivision of suborders according to similar kind, arrangement, and degree of expression of horizons, with emphasis on upper cecum, base status, soil temperature, and moisture regimes, the presence or absence of diagnostic layers like the plinthite, fragipan, and duripan. Then we have the subgroup, which is the central concept taxa for grade groups, and properties indicating integration to other grade groups, suborders, and orders. Then we also have family, which is the properties important for plant growth, broad soil textural classes, average over control section or solum, the mineralogical classes for dominant mineralogy of solum, soil temperature classes based on the mean annual soil temperature at 50 centimeter depth. And then, of course, we have the series. These are kind and arrangement of horizons, color, texture, structure, consistency, and reactions of horizons, chemical and mineralogical properties of the horizon. Here we have the soil description. Fine, loamy, mixed, superactive, mesic, aquic, are geodols. When you have this description, you will know what is the order of that soil by looking at the last syllable of that description. So in this case, all stands for mollisols. We're going to talk one by one. So the order is the highest and most general of the soil classification system that is similar to the phylum in plant taxonomy. And these are based on conditions under which the soil developed. So order, siya yung pinakamataas. Then we have suborder. There are 54 suborders. So here on the description, so we have here udols. So we have here argiodols. Also we know that it's the order. Ud means the suborder. So in this case, we have here the eudic moisture. And this is grouped by similarities in soil formation such as wetter or drier soil or colder or warmer soil. So in this case, ud means eudic moisture regime. So that is the suborder. And then we have the grade groups. So there are 211 grade groups. So in this case, we have here the Argi. Argi is the grade group, which means there is a clay accumulation from the argillic subsurface horizon. So Argi means clay accumulations. This is based on differences between soil horizons. We have the subgroup. There are more than 1,100 subgroups. So in this case, we have the aquic. Aquic means aqua, di ba? Pag aqua, ibig sabihin tubig. So, wet ang kanyang lupa. It describes a profile characteristics, wetness, sound tonguing of E, horizon, and others. So that is the subgroup aquic. And then we have the family. The family stands for the fine, loamy, mixed, superactive, mesic. So this is based on soil properties that affect management and root penetration, such as texture, clay minerals, CEC, temperature, and depth. That is the family. And then we have the series. Series is the name from the town or landscape feature near where the soil was first recognized. So usually pinapangalan nila ito sa place, sa lugar kung saan nila unang na-describe yung lupa na yon. Like for example, Matina, San Manuel, Lipa, Camansa, Louisiana, Cabangan, Cabacan City. So there's a lot of cities in the Philippines. So in detailed field soil survey, soil cities are sometimes further differentiated based on their soil texture, degree of erosion, slope, or other characteristics. So when you have a soil survey report, usually sa isang series na ganyan, so they are also subdivided or subclassified into different series, which is based on their texture, degree of erosion, slope, or other characteristics. So in this case, you can find San Manuel yung kanyang soil series, but then you can still find San Manuel silt loam, San Manuel loam, or San Manuel other. Yeah. So we have here Maasin clay series, San Manuel silt loam, Matina clay loam, and others. So that is the series. Each country has their own series classification of the soils, depende kung saan nila unang nakita yung lupa na yon. So in the Philippines, Bureau of Soil Water Management, in cooperation with Department of Agriculture, are the main agencies who are responsible for classifying our soils. So if you go to your Department of Agriculture or to the Bureau of Soils, BSWM, you can always ask for the soil survey report. And then nakadiscuss doon kung ano yung properties ng series na yun. Now we will go to the different soil orders. So as I've mentioned, there are 12 soil orders. Each order is largely based on the presence or absence of major diagnostic horizon, the epipedon, na-mention na natin yung kanina. And these soils are classified due to their common properties. And note that all orders have a common ending sol. Solum in Latin, which is soils. Also in French, they called soil as sol. So we are going to discuss entisol, inceptisols, andisols, podosols, mollisols, alphisols, ultisols, oxysols, aridisols, vertisols, histosols, and jellysols. If you want more detail, you can always look for the website for soil orders. I put it down. Entisol. So entisol, you can just remember the word ent. Ent from the word recent. Recent meaning bago. So because bago pa yung lupa na to, there is little, if any, profile development. So primitive soils, very young ang kanyang lupa. So dahil nga bata pa siya, so you can just see the A and the C horizon. So A, and then makikita mo na ngayon yung kanyang, malapit na siya ngayon sa bedrock. So A, C horizon. So this is recent entisol. They are weakly developed mineral soils without natural genetic, so wala siyang subsurface, horizon, or with only the beginnings of such horizons, such as AC profile setup. They have most an ocric epipedon and have a few human-made anthropic or agri epipedon. So, ito yung entisole. So, lighter yung kanyang color. So, there is a minimal development and there is little horizonation. Hindi pa ganun ka-develop, so wala ka pa makikita masyadong different horizons. So, that is entisole. And there are two reasons why these soils lack greater development. Una, the parent material has such highly resistant minerals that rate of weathering is very slow. Medyo matagal mag-weather yung kanyang parent material, kaya mabagal din ang kanyang development. Second is the exposed land surface is young as a result of erosion or burial under new material brought about by wind, water, or agents. And droughty sand stays young as its content is high in particles of inert resistant mineral quartz or they are gradually eroded. These are usually found on steep slopes and dunes which are commonly eroded pag masyadong mabilis yung kanyang erosion because the top layer slides or blows away, exposing new materials below which keep the soil young. The opposite process keeps alluvial and wetland soils young as new material is added layer by layer when flood water moves over the soil or as temporary ponds spread across them. So the entisoles are usually found in very dry or cool locations affecting the weathering process. So dahil dyan, medyo less yung kanyang weathering process. So hindi siya ganun ka-develop yung kanyang horizons. Weathering is slowed down because of that. Second order that we're going to discuss is inceptisoles. So unlike entisole, inceptisole, we have here inceptum, which means beginning. Inception means start, beginning. So the soil shows the beginning of horizon development with little or no elevation. This is 15.8% of the world's soils, and it has an ocric or umbric epipedon plus cambic subsurface horizon. The embryonic soils with few diagnostic features. Hindi mo pa siya ngayon makikita masyado yung kanyang differentiation. There will be recent deposits in valleys or deltas. So, kakastart pa lang ng kanyang profile development. Most inceptisoles occur in geologically young sediments like alluvium, colluviums are loose, and they are commonly found throughout the world and are prominent in mountainous areas. And the parent materials, which are highly calcareous or resistant to weathering, inhibit soil development. And the natural productivity of these soils varies widely and is dependent upon clay and organic matter content and other edaphic or plant-related factors. So, kung matatandaan nyo dun sa entisole, kita mo yung C horizon and then A horizon, di ba? From A and then direct to C horizon. Dito naman sa inceptisole, meron ka na ngayon makikitang A, B, W, and then we have here the C1 and the C2. Meaning yung C horizon ay nagwe-weather na siya ngayon. Kaya meron na siya ngayong C1 at saka C2. Yun nga lang, hindi pa siya ganun ka fully defined kasi kakastart pa lang niya ngayong mag-develop. So this is inceptisole, beginning inception. The third order, andisole, from the word ando. Ando in Japanese means dark black soil. Ando. This is usually formed on volcanic ash and cinders and commonly found near the volcano source or in areas downwind from the volcano where a thick layer of volcanic ash had been deposited during eruptions. So these are volcanic soils, and they do not have time to become highly weathered, which the principal soil forming process was the rapid weathering of volcanic ash to produce amorphous or poorly crystallized silicate minerals such as allophane or immogolite and ferrihydrite, the iron oxyhydroxide. So ang tandaan nyo is, ando in Japanese is dark black soil coming from volcano. So these are usually volcanic soil. Andesol. So they are black because of the accumulation of organic matter, but it is not enough to have histid epipedon because of its protection aluminum humus complexes. They are young soils just like entisols and inceptisols and believed to have developed for about 5,000 to 10,000 years. In soils, 10,000 years is still very, very young. And they have unique andic properties in at least 35 centimeter of the upper 60 centimeter of soil. These andic properties are characterized by a high content of volcanic glass and or high content of amorphous or poorly crystalline iron and aluminum minerals. So because of the presence of these minerals and high organic matter, a light fluffy soils which has low bulk density, hindi siya compacted, they are easy to till but they have a higher water holding capacity and resistant to erosion by water have been developed. So they are usually found in regions where rainfall keeps them from being susceptible to erosion by wind, and they are high in natural fertility. Most of the andesols are high in fertility except for the phosphorus availability. Mababa ang kanyang hindi available ngayon ang phosphorus in this type of soil because of extremely high phosphorus retention capacity of the andic materials. So to overcome these difficulties, proper management of fertilizers and plant residues should be employed in andesols. Some andesols have melanic epipedon, a diagnostic surface horizon that has high organic matter content and dark color. So that is andesol. Fourth order is spodosol. Spodos is a Greek word means wood ash. Ash ng wood. This is commonly formed in sandy parent material under coniferous forests. So when we say coniferous forests, these are vegetation which has some needle leaves trees like pine trees. Coniferous. So we have cones from that. So, and the acid sandy soils with thick albic horizons. When we say albic, di ba, yung light ang kanyang color. So bleach. And red BHS with ochric and spodic. And they are coarse textured and they have high leaching potential. This is 5.4% of the world's soil. Are from weathered materials from rocks, poor in calcium and magnesium, such as sandstone and granite. They have a subsoil accumulation of organic matter along with aluminum and iron oxides called a spodic horizon. And they are typically low in natural fertility kasi mababa ngayon yung kanyang basic at ions. They are mostly leach, the calcium, magnesium, and potassium, and they are now high in soil acidity because due to the presence of hydrogen and aluminum. So because acidic nga siya, these soils require extensive inputs of lime and fertilizers to be agriculturally productive. Then we have mollisol. Mollisol, from the word molu, mollis, which means soft. So these are soils with thick, dark, soft surface. It has a molic, cambic, nitric epipedon, and they have high base saturation, and you can find them in the prairie or under grassland vegetation that has extensive fibrous root system with some broadleaf forest covered soils. Most of the mollisols are formed in calcareous rich deposits and develop in residuum weathered from sedimentary rocks. They are generally very fertile for plant growth due to the clay and organic matter content. And these soils are typically well saturated with basic ions such as calcium, magnesium, sodium, and potassium, which are essential nutrients for plants, and they are considered to be among the most fertile soils on Earth. So these are some of the mollysols found in Kansas that is developed from limestone bedrock calcareous soils. And we also have another picture here, formed in a new parent material, loose, that buried the original soil. Then we have alphisol. Alphisol, there is no derivation. This is found under forest and savanna vegetation with ochric and argillic epipedon, with high base saturation, which is higher than 35%. This is 7% of the world's soils, and they are developed in humid and subhumid climates and have an annual precipitation of 500 to 1,300 millimeter. Common siya ngayon sa humid areas, so mataas yung kanyang rainfall. Most of the clays are translocated into the B horizon. So there is a clay accumulation in the B horizon, and it has a thick E horizon, yung bleach horizon.
The available water much of the growing season and is considered to be greater than that of aldisols, but less than of mollysols. These are generally fertile and productive, typically have a high concentration of nutrients such as calcium, magnesium, sodium, and potassium, and forms in regions with sufficient moisture for plants for at least part of the year. Then we go to Ultisos ultimus or ultimatum. Ultimatum. Bigyan kita ngayon ng ultimatum, meaning last chance. Ultimus, which means last. Ult, last. This is intensely weathered soils of warm and humid climates, typically formed on older geologic locations in parent materials that is already extensively weathered. So very old na yung lupa. It undergoes a lot of weathering, and that's why there's a lot of horizons na na-form. It has ochric and argillic epipedon. It has low base saturation, less than 35%. They are red and strongly acidic due to leaching of the basic ions. What is left are just the aluminum and the hydrogen and iron. And they have an accumulated clay minerals in the B horizon. And this consists 8.5% of the world's soils. Ultisol. Although generally low in natural fertility and high in soil acidity, the clay content of ultisols give them a nutrient retention capacity greater than that of oxysol, but less than alphisols or mollysols. Because weathered na nga yung lupa, so there will be a lot of clay. Because of high clay content, it can retain now a lot of nutrients. It gives them the nutrient retention capacity higher than that of oxysol. Yun nga lang, medyo mababa siya kumpara sa alphisols or mollysols. These soils are commonly found in areas with high precipitation, yung maulan, rapid weathering, and rapid leaching of bases. And they can be agriculturally productive with inputs of lime and fertilizers. That is ultisol. Then, of course, we have oxysol. Oxysol words, it's coming from the word oxide. These are soils with oxic horizon, very red soils. They are highly weathered soils of the tropics where few original minerals are left unweathered. So very, very weathered siya. They are formed in hot, humid climates that receive a lot of rainfall, so the soils are extensively leached, and the clay-sized particles are dominated by oxides of iron and aluminum, which are low in natural fertility and high in soil acidity. Oxysalts are located primarily in equatorial regions, which is very hot. In the Philippines, we have a lot of oxysalts also. So these are high in 1:1 clay mineral, the kaolinite. They are 9.2 of the world's soils. They are often are over 3-meter depth. Malalim siya, guys. Kasi these soils are old soils, so matagal na rin siyang na-form. Kaya siya malalim na yung kanyang development, profile development. You can find oxysalts in the old fluvial terraces on high-lying old erosion surfaces. The paired materials are mostly consist of quartz, 1:1 clays, iron, and aluminum oxides, and they are typically physically stable with low shrink swell properties and good erosion resistance. And these soils require extensive inputs of lime and fertilizers to become agricultural productive. Kasi nga, mababa na kanyang fertility. Because most of the cations are leached, leaving only the iron and aluminum oxides. If you compare the fertility of oxysols and ultisols, mas fertile ngayon, although pareho silang mababa ang kanyang fertility, pero mas lamang ngayon ang ultisols kumpara sa oxysols. Then, of course, we have the aridisol. From the word arid, aridus, id, which means dry. So these soils are commonly found in arid regions with less than 10 inches or less than 254 millimeter rainfall. So masyadong dry, hindi siya maulan, guys. So there will be like in deserts, and there will be water deficiencies. So most arid soils contain sufficient amount of water to support plant growth for no more than 90 consecutive days. So less than 3 months lang kung yung kanyang capacity to supply water to plants. The rest of the year, they are dry. They usually contain high levels of calcium, carbonates, gypsum, and sodium. Because of high temperature, most of these material tend to be pulled up in the surface. And this is 19% of the world's soils, one of the most prevalent in the whole world. We have ochric and cambic or argillic or other diagnostic feature. They have horizons of lime or gypsum accumulation, and they often have a surface horizon that is pale in color and low in organic matter. So maputi siya, guys, or lighter yung kanyang color, at saka mababa din ang kanyang organic matter content. And you can find salty layers in A or the BT horizons, and the sodium chloride like salt accumulates on the surface and in the subsurface. During salt formation, so kita nyo yan dyan, guys, meron siya ngayong salt na nag-accumulate in the surface, and even in the subsurface, there are also some traces of salts. During salt formation, soluble salts translocated to a subsurface horizon. However, since there is kulang ngayong ulan, there is insufficient rainfall to leach salts from the soil profile, the soluble salts accumulate. And due to limited moisture and accumulated soluble salts, these soils are generally not suited for major crop production. Very mataas yung kanyang salts, and this can affect and damage crops. However, if properly managed and irrigated, because you leach down the salts, these soils may become productive. And these are notable soils in Maui in Hawaii that are classified as arid soils, but they are notable for their unique fertility. In Hawaii, they were able to maximize the potential of these aridisols by irrigating those soils and implementing other good management. Then we have vertisol. Vertisol comes from the word verto, which means turn. Verto, turning.
because these soils are inverted soils with high clay content. Masyadong mataas yung kanyang clay content, and they have large shrink swell capacity potential and gradually invert on themselves depending on water content. So, pwede siyang mag-shrink, pwede siyang mag-swell depending on the water content. This is 2.1% of the world's soils. They have molic or ochric epipedon, and they exist mostly in temperate to tropical climate with distinct wet and dry seasons. They have high clay content that swell when wet and then shrinks as they dry, forming large, deep cracks. Vertisols are usually very dark in color with widely variable organic matter content, which is between 1 to 6%, and they typically form in calcium and magnesium rich materials such as limestone, basalt, or in areas of topographic depression that collect as elements leached from uplands. And they are commonly formed in warm, subhumid, or semi-arid climates where the natural vegetation is predominantly grass, savanna, open forest, or desert shrubs. Then we have histosol. Histo, from the word histos, which means tissue. Histology, diba? Histology means tissue. So that is histosol. And that is usually associated with peat and muck soils where you can still find the tissue, the debris, plant debris or animal debris. So it has histic epipedon, which is incompletely decomposed plant remains with or without mixtures of sand, silt, or clay. So basically, guys, these histosols are organic, full of organic material. You can still find some of the tissues of the plants or the animals. This is 8.5% of the world's soils, and the organic soils consisting of variable depths of accumulated plant remains in bogs, marshes, and swamps. So the peat and muck soils are usually classified, are part of this order, histosol. Yung mga huyong-huyong. In Davao, we have a lot of peat soils. It occurs extensively in boreal, Arctic, and subarctic regions. And elsewhere, they are confined to poorly drained basins and depressions like swamps and marshlands with shallow groundwater where restricted drainage inhibits the decomposition of plant and animal remains, allowing these organic materials to accumulate over time. So the sustainable use of peatlands is limited to extensive forms of forestry or grazing, and if carefully managed, the histosols can be very productive under capital-intensive forms of arable cropping or horticulture at the cost of sharply increased mineralization losses. The deep peat formations and peat in northern groups are best left untouched. And in places, peat bogs are mined for production of growth substrate for horticulture or to fuel power stations. I know a lot of, in Davao del Norte, there's a lot of peat soils, and some of the plantations are even using areas with peat soils for banana plantations. And then the last but not the least soil order is gelisol. From the word gel, gel. Soils with gelic materials underlain by permafrost or frozen soil within 2 meters of the surface. Meron siyang frozen materials. Generally have limited profile development, and most of the soil forming processes in these soils occur near the surface, sometimes resulting in significant accumulation of organic matter, and the permafrost of gelisols tend to become unstable or they melt if disturbed, leading to a waterlogged soil condition that poses problem for engineering. So frozen siya, guys. The permafrost influences pedogenesis by acting as barrier to the downward movement of the soil solution, and the frost mixing or the cryoturbation is an important
process. In jelly soil, there are three suborders. So we have histels, turbels, and orthels. Histels are these are jelly soil which has an histic epipedon. So meron siyang mga tissues, organic matter. So rich in organic matter. Turbels naman ngayon when there is evidence of cryoturbation. Cryoturbation is when there is a mixing of frost. And orthels naman ngayon when it's not histels or turbels. Those are the 12 soil orders. But what about in the Philippines? What are the soil orders in the Philippines? Most of the lands in the Philippines are hilly to mountainous. Approximately 55% of the country's land area is steeper than 18%. Of course, we also have plains, but then 55% are hilly to mountainous. Geomorphology is varied because some islands are made up entirely of raised coral reefs and others are island volcanoes. So we have different kinds of morphology in the Philippines depending upon the provinces. Kasi may mga mountainous areas, mayroon namang iba na malapit sa mga dagat, mayroon namang iba na kabundukan. So, the land use classification is classified as lowland and upland. Lowland soils are mostly fertile due to accumulation of clays, nutrients, and water coming from the upland soils where leaching and erosion are common. If you happen to know where is the most fertile area in Davao City, then the answer is the downtown area because most of the materials coming from the mountains are accumulated and deposited in the downtown area. Yun nga lang, downtown area is not used for agriculture. This is usually used for commercial purposes. So, yun. But then, most of the lowlands are fertile. This is based on the report by Jose de Rondal from JERCAS 2005. So I put it there, guys, in case you would like more information. So based on the Bureau of Soil and Water Management, or the BSWM, soil taxonomy, there are 9 soil orders in the country. In the Philippines, so we have, you remember we discussed about the 12 soil orders, but then in the Philippines, 9 of those 12 soil orders exist. So we have insectisols, which is 39.9%, ultisols, 26.6%, alphisols, 17.1%, entisols, 8.1%, vertisols, 4.5%, mollisols, 3.8%, andisols from the volcanic soils, 0.23%, and oxysols, we have the 0.2%, and some limited histosols. So the source of that is Picard from 2006. So the ultisols, alphisols, oxysols, and some families of insectisols and entisols belong to the upland category, while vertisols and most of the families of insectisols and entisols belong to the lowland category. I think this is very, very helpful that they conducted a soil survey and classification so that we know what are the properties of those soils. I think meron silang provinces, guys, na conduct ng mga soil survey. So if you have time, you can always visit your provincial agriculture office to search for the common orders or common cities in your provinces. So this is a table adapted from Badayos in 1994, so Sir Rod Badayos. So, mas recent yung sa Picard. In 1994, there's only 6 orders, classification in the Philippines. But then in 2006, there were already 9 soil orders. So that ends our topic about soil orders. Sana meron kayo natutunan and you learned about the different characteristics of the different soil orders. Thank you very much and see you again next time. Bye!